Okay, welcome back. Now we're gonna look after doing simultaneous equations, right? Of linear and non-linear one. I hope you have already we've looked at a few different types here. So we have practice now 7a. Question 1, we have a linear equation with a non-linear equation over here. So we have x squared minus 3y plus x equals 9 and x plus 2y equals 5, and we see that you have two answers here. And then subsequently, we have also one answer for certain type of equations. So if you look at question 2, we have x squared minus 2x. In this case, x squared minus 2x plus 4y equals 5, and a linear equation of y equals to half x plus 5 over 4. We see that we only have one solution. And for question 3, actually we will come to a stage where when we use b squared minus 4ac, its solution is actually negative 54. But the common thing is between all these four examples here is that when you combine two of these equations, you will actually get a resultant resultant quadratic equation. So I say again, when you combine two of them, you will in fact get a resultant quadratic equation. Now this quadratic equation, if you think about it, if you use b squared minus 4ac, okay, and for this case, alright, if I use the b squared minus 4ac for this equation, which is I have reduced it to 6x squared plus x minus 5 equals to 0, its discriminant is actually positive. Okay, and since it is positive, and we have also solved the equation, so it has two solutions, right? Two solutions. And in some sense, on the graph, this would actually simply mean that if I have an x-axis and a y-axis, okay, this would mean that if there is a the first equation, which is a quadratic curve, and I have a linear line, which is something like that, this is just a sketch, I will meet the curve and the line will meet at two unique points. Alright, so in this case, we can actually kind of see a pattern here, right? Discriminant is more than 0 for the resultant equation. The original equation that I have here will meet at 2 points. For the second one over here, you also be able to see that since I have two solutions, its discriminant is also positive, right? Can you see that it has two solutions? So this would also mean that actually there's some pattern I can do here, which is using the discriminant of the resultant equation. So the resultant equation here is in fact 2x squared plus 5x minus 33. This is the resulting equation of combining the linear and the non-linear equation. Now if you look at question 2 over here, okay, the discriminant here is in fact equals to 0. And where do I get this discriminant from? I got it from the resultant equation. The resultant equation is in fact x squared equals to 0. Hey, but where is the b, where is the a, where is the c? So if you're thinking about it, this is in fact just x squared plus 0x plus 0 is equals to 0. So this is the resultant equation, and it will give us only one solution. One solution would mean that if I have a curve, okay, I'm not drawing the curve very well, but let's try to do it better. Okay, if I have a curve, the line will meet the curve at only one point. So it will meet at only one point. Okay, so that's why it has only one solution, x equals to 0 and y equals to 5 over 4. Now, for the last question over here, because b squared minus 4ac is actually less than 0, in fact, the thing we can make here, the deduction we can make here, is that if between the quadratic curve and the line, they do not meet at all. So it can be something like that. Okay, so when they do not meet, they are discriminant of the resultant equation. I say again, the resultant equation. The resultant equation will, you can use the discriminant of the resultant equation to determine whether the curve of the original equation and the linear line will actually meet. So between the intersection of a line and a curve, if the line cuts the curve at two distinct points, we can make a conclusion that the discriminant of the resultant equation. So discriminant of resultant equation. Okay, resultant just means after you combine using substitution method to combine, your discriminant here will be more than 0. Okay, so we're gonna actually talk about the resultant one. So that's why I'm gonna duplicate this, and you're gonna just kind of plug them here, duplicate, plug them here. Okay, so in this case, the second case is if it touches at only one point, b squared minus 4ac will be equals to 0. And last but not least, if the line does not even intersect the curve, okay, the discriminant will be less than 0. So this is actually how you can use discriminant to actually figure out whether a curve and a line actually intersect at 2 points, 1 point, or totally don't intersect at all. Okay, one example I'm going to use is, for example, question 1 part 1. You're supposed to actually kind of solve it, right? So you have two equations here, x plus y equals to 7 and x squared plus xy minus 2y squared equals to 10. You figure out some steps and you will come to a resultant equation, which is 2x squared minus 35x plus 108 equals 0. And then this is a factorizable one, and you will get two answers of x. And with two answers of x means you have it actually tells you it cuts at 2 points. So in this case, you will sub each of these value, okay, each of this value into maybe the linear one to find the point that you need to find. So in this case, I find 2 points, and the coordinates of the intersection points are simply just the x and y values that you found in part 1. So this example is actually pretty straightforward. It's nothing too difficult, and that is how you tell between how you use discriminant to actually tell if the quadratic curve and a linear line intersects. That will be all. See ya.